Okay, so we're going to talk about milk synthesis. For some of you, most of you, this is a review. Others, it'll be there for the first time, but we want to think about how do we get to milk as part of our discussion of mammary physiology. What's in milk? So we think about all the things that are there. We've got water in the high 80s as a percentage, fat 3, 4, 5, 6 depending on stage of lactation, whether it's colostrum or not, what breed you're dealing with, protein, uh, 3, 4, 5 range, depending again on those factors, stage of lactation, breed, lactose constant, more or less at 4.8. And then we have the minerals, vitamins, and all the other things that people say are there, the probiotics and stuff like that. So how do we get from feed to milk? And we're going to focus on the organic components, the fat, the protein, and the lactose. So if we look at our cell here, our representative cell, lactating cow, we've got the basement membrane here, more or less. We've got the capillary down here. You've got the whole alveolus all the way around. Nutrients go from the capillary across the basement membrane into the cell, and they're used to generate cellular components. The nice thing about this particular diagram is as we secrete into the lumen of the alveolus over here, we notice that the proteins are let out as individual molecules, whereas our fat droplets, as they form, they're going to leave with a layer of plasma membrane around them. And that's one of the things that we kind of have to keep intact. If those start to break apart, we'll get some rancid tastes and stuff as the fat breaks down and things like that. But you've got a lighter than water droplet here, and then osmotically active proteins that are secreted in. Lactose is very similar, secrete the individual lactose molecules out into the lumen of the alveolus. So here's that fat droplet being pushed out from the inside of the cell on the basement membrane, lumen out here. You've got the plasma membrane around the outside, and then the fat molecule being uh, exported. And because we have that plasma membrane around the outside, we have something that's at least semi-water soluble. It's going to semi-mix. It's always going to float to the top. If you were like me, raised on raw milk, the droplets always go to the top. And me and my brothers always talk about, even though we haven't had raw milk in a while, we always shake our milk jugs before we pour them. So it's a habit we've had since we were kids. Look at the overall schematic of how these three milk components are formed. This is what we would do all at once. So we start over here in the rumen reticulum. What's formed there goes to the small intestines. Absorption goes to the liver first, moves throughout the body, through the blood, ends up at the mammary gland, and then we secrete from the secretory tissue fat, lactose, protein. As I did in A and P, we'll use black as our paths and parts, green ink as our nutrients or our compounds, and then the blue are processes that occur along the way. So we have all three here. We'll break them down one at a time so we can go through them. Let's start with milk fat. We know that milk fat, half of it is transferred from the blood to the milk, and the other half is made in the mammary gland. The building blocks for the triglyceride are the glucose, which forms the glycerol, that backbone, and then the acetate is used to form the fatty acids that hang off of that glycerol. So triglycerides, 50%, are going to come from de novo synthesis or being manufactured in the mammary gland. The other 50% of the milk fat is due to transfer that can either come off her back, so adipose tissue synthesis and degradation of fats, those can empty out off her back, go to the blood, and be transferred to the milk. In early lactation, if she's not feeling so good, losing a lot of body condition, there can be a severe dump of those adipose tissues, a whole lot of fat here, and maybe more than 50% gets transferred here. We get artificially high milk fats in that situation. The other source for our pre-made fat, we got the adipose. We also have the stuff from her diet. So both of those can go to the pool in the blood, and they are transferred without much change to the milk. So acetate is going to come directly from the acetate in the rumen. Propionate is going to go to the liver. We take two of those. We go through gluconeogenesis. That forms glucose. Glucose goes to the blood, released from the liver, and that is used to make the glycerol for the fat. As a general rule, butyrate is used by the gut and oxidized to CO2 and water. So that's fat. We focus on lactose. We're looking for the building blocks of galactose and glucose put together. So two 6-carbon molecules go together to form lactose. These two, that lactose synthesis in here, comes from the glucose. Both glucoses are two glucoses absorbed. One remains unchanged. One gets moved around, rearranged, isomerized, and we stick the two together there. So most of the glucose is going to come from ruminal propionate, one of the 3 fatty acids. Again, absorbed, goes to the liver, gluconeogenesis, glucose. Most of the glucose that ends up in lactose originally comes from propionate. If we focus on the protein, we need amino acids that are in the blood. They are going to be absorbed into the mammary gland, the secretory tissue. They're going to be put together into milk proteins. Those amino acids can come from 3 different sources. They can come from the muscle, body condition broken down. Those amino acids transferred through the blood to the mammary gland. They're going to add into that pool. Our other 2 are, depending on how the rumen works, we're going to have a certain amount of microbial protein produced in the rumen. A certain amount of feed protein is going to pass through the rumen untouched. Those protein molecules are broken down in the small intestine to amino acids. So we have microbial amino acids and feed amino acids. They're going into the one pool of amino acids, and those amino acids sorted, distributed, changed, altered, whatever, at the liver, become part of the blood pool, and microbial, feed, and muscle amino acids contribute to the mammary gland, where they're formed into milk proteins. So that's all of them back together. We got our raw building blocks: acetate, propionate, microbial protein, feed protein, more or less, are going to be broken down, absorbed, and become building blocks for our 3 components. We can also take stuff off the back, body condition, from the fat tissue, the adipose tissue, or the muscle. and they can contribute to building blocks that are going to form milk.